Hi, this is Archana working as assistant professor in Chabrol Engineering College. In previous video lecture, I explained what is meant by the arc, how it will be produced, what are the arc extension methods, arc voltage and also restriking and recovery voltage. The contents of the present video lecture are expression for the restriking voltage, average and maximum value of RRRV, that is the rate of rise of restriking voltage, current chopping and resistance switching. The expression for restriking voltage is, first, what is meant by the restriking voltage? It is the transient voltage that appear across the breaker contacts after opening of the breaker. For every current zero interruption, the arc interrupted but it does not normalize instantly, it will be oscillated. There will be a transient condition at this interruption of the arc. The voltage across the contacts is known as the restriking voltage. This is the current zero interruption. For every current zero interruption, the arc interrupted, but it does not normalized instantly. It will be oscillated like this. There will be a transient condition at this interruption of the arc. The voltage across the contacts is known as the restriking voltage. Next, what is the expression for the restriking voltage? This is the single line diagram of a bus bar. In that bus bar, we are connecting the one feeder line, taking the one bus bar. This is the bus bar. In that bus bar, we are connecting the feeder line. In that feeder line, a fault will be obtained. Due to the fault, the contact of the breaker may be open. In that feeder line, the fault, this is the fault. The fault will be obtained. Due to that fault, the contacts of the breaker may be open. Then the arc struck in between the contacts of the breaker. For every current zero interruption, the arc may be executed, but it does not normalize instantly like this. It may be oscillated like this. At the starting of the oscillation, there is the voltage may be appeared. This voltage may be calculated by using the equivalent circuit. This voltage may be calculated by using the equivalent circuit. This is the equivalent circuit of a single line diagram. In that, V equal to Vm sin omega t, and then we are having the inductive coil and resistance and capacitance and circuit breaker. This is the fault. When the fault will be obtained in the feeder line, it will be short circuited like this. This is the equivalent circuit diagram of a single line diagram. Next, coming to the expression, when the breaker contacts are open and are finally extinguished at the some current zero, a arc voltage is suddenly applied across the capacitor. The voltage that will be appeared across the capacitor and across the circuit breaker also. In that equivalent diagram, we are having the inductance and capacitance. The inductance and the capacitance are there. Therefore, the total current I equal to the IL plus IC. Total current I equal to the IL plus IC, or I equal to the current across the inductance is the 1 by L integral V dt, and the voltage across the current across the capacitor is C dV by dt. C dV by dt. This is the current equation for equivalent circuit. Then differentiate on both sides. Therefore, di by dt equal to V by L plus C dV by dt square. In the equation C is also there. C dV square V by dt square. But I equal to 1 plus Vm by omega L, omega cos omega t. Normally the current I equal to 1 plus Vm by omega L, omega cos omega t, or differentiating both sides. Di by dt equal to Vm by omega L, omega cos omega t. At t equal to 0, substitute t will be replaced by 0. Then cos 0 will be equal to the 1. Therefore, di by dt. Therefore, the di by dt equal to the Vm by L. Di by dt equal to Vm by L. Now substitute di by dt is replaced by Vm by L. Di by dt is replaced by Vm by L. That equal to V by L plus CD square V by dt. CD square V by dt. Next, that is equivalent to the V equal to Vm into 1 minus cos of 1 by root LC. 1 minus cos of 1 by root LC. Therefore, V equal to Vm into 1 minus 2 pi Fn t, where Fn is the 1 by 2 pi root LC. Fn is the 1 by 2 pi root LC. This is the natural frequency. Okay, this is the voltage expression for the restriking voltage. The voltage obtained across the contact of the circuit breaker at the starting instant of oscillation is the V equal to Vm into 1 minus cos 2 pi Fn t. This is the expression for the restriking voltage. Next, average and maximum rate of rise of restriking voltage. It is also called as the RRRV, rate of rise of restriking voltage. It is defined as the peak transient recovery voltage divided by the total time 0 from 0 voltage to peak voltage. It is the ratio of transient voltage to the voltage of 0 voltage to the peak voltage. 0 voltage to the peak voltage. The restriking voltage formula V equal to Vm into 1 minus cos 1 by root LC. 1 by root LC. Therefore, we find out the rate of rise of restriking voltage is differentiating on both sides. Then we obtaining the dV by dt equal to Vm by root LC. Vm by root LC sine cos integration sine minus sine, then sine t by root LC, minus minus gets cancelled, then sine 1 by root LC. Differentiating on both sides, we get the dV by dt equal to Vm by root LC sine 1 by root LC. Therefore, the RRV will be maximum when the sine 1 by root LC equal to 1. 1 by root LC equal to 1, or t equal to pi by 2 root LC, t equal to pi by 2 root LC. Hence, the maximum value of RRV is substitute sine 1 by root LC equal to 1. Then Vmax equal to sine term will be 1, Therefore, RRV of maximum value is the Vm by root LC. Vm by root LC. This is the maximum value of RRV and this is the average value of the RRV. This is the maximum value of the RRV. Further, the peak of the restriking voltage occur when the V is maximum. V is maximum means substitute sin 1 by root LC equal to 0. Therefore, the dV by dt equal to 0. Therefore, dV by dt equal to 0. This is the average and maximum values of a RRV, or rate of rise of restriking voltage. Next topic is the current chopping. Current chopping. It is defined as the phenomena in which current is forcibly interrupted before the natural current 0. Before the natural current 0. It means before the natural current 0, the current is forcibly interrupted. For every half cycle, the current may be natural 0. In that condition, the arc may be extinguished. Before the natural current 0, the current is forcibly interrupted. The current is forcibly interrupted is known as a current chopping. It is observed in the vacuum and the air blast circuit breakers only. In air blast and vacuum circuit breakers, the fault clearing capacity is fixed and the independent of the fault current is level. In this case, when the breaker is used to break the circuit of unloaded transformer or shunt reactor, there will be brought to 0 before natural 0 current. Okay, this is because the breaker is interrupted only the magnetizing currents, which is very less compared to the full load current or fault current. As the capability of breaker arc extension is high enough, therefore the low magnetizing currents will be brought to 0. Before the natural current 0, the low magnetizing currents will brought to the 0 position. This phenomena is known as the current chopping. Current chopping means the before natural current 0, the current is forcibly interrupted is known as the current chopping. Okay, in this figure L is the shunt reactor. In this figure, L is the shunt reactor and C is the capacitance of winding and R is the eddy current losses in the reactor. This is the circuit breaker, air blast circuit breaker. We know the shunt reactor also. This is the inductance is the shunt reactor. We know that the shunt reactor also takes magnetizing current. This reactor takes the magnetizing current at every time. This magnetizing current is low under normal conditions. Normal conditions means if any fault will be obtained in the line, the magnetizing current is low. The current flowing through the reactor is I. The current flowing through this reactor is the I, and hence stored magnetic energy in it Li square by 2. The stored magnetic energy in the shunt reactor is Li square by 2. But as soon as the breaker is open, the current chopping will take place. If the breaker contacts be open, the current chopping will take place. Current chopping means the before natural current is 0, the current forcibly interrupted in this condition. The current through the reactor becomes 0. In this case, the current through the reactor 0. Due to this sudden drops of current through the inductor, due to this sudden drops across the inductor, a high voltage will be developed across it. A high voltage will be developed across it according to the Faraday's laws. According to the Faraday's law, the high voltage will be developed. Therefore, the voltage across the capacitor will also rises. Therefore, the voltage across this capacitor will also rises. Consider a shunt reactor as shown in the figure. The reactor takes the magnetizing current under normal operating conditions, and that means the no fault condition. The reactor takes the magnetizing current. When the breaker opens, the current chopping will take place and current through the reactor becomes 0. Due to sudden drop of the current through the inductor, a high voltage will develop across it. Okay, next, the stored energy in the reactor transferred to the capacitor. The stored energy in the reactor is transferred to the capacitor. The stored energy in the inductor of reactor is basically transferred to the capacitor. Mathematically, it will be expressed as Li square by 2. Li square by 2 equal to Cv square by 2 equal to the Cv square by 2. Here V is the voltage across the capacitor. Here V is the voltage across the capacitor. Thus, V equal to I by root Lc. Thus, V equal to the voltage across the capacitor is equal to I by root Lc. This is the prospective voltage across the capacitor during the current chopping. This is the I by root Lc. I by root Lc is the prospective voltage across the capacitor during the current chopping. During the current chopping. By observing this figure, you can see 4 current choppings. By observing this figure, we can see the 4 current choppings. This is the 4 steps. Okay, this is the 4 steps of chopping. Starting is this is the first current chopping, and ending one is the final current chopping. In between the first to final, we are having the 4 current choppings. By observing the figure, we can see the 4 current choppings. In each current chopping, the magnitudes of the current reduces. This is the magnitudes of the current in each and every current chopping. By observing these current choppings, each and every current chopping, the magnitude of currents reduces. This is because of damping effect of loss in the equivalent like eddy current and hysteresis losses. Okay, like eddy current and hysteresis losses. Due to that losses, the magnitude of the current may be reduced and it may be 0 for the final chopping. This is known as the current chopping. This is the first current chopping and this is the final current chopping. This is the natural current 0. Before obtaining the natural current 0, forcefully the current may be reached to 0 position. It is known as the current chopping. It is known as the current chopping. This is the arc current. Next one is the arc voltage. This is the restriking voltage. It's at the end of the oscillation, we are known as the recovery voltage. Starting one is the restriking voltage and starting of the oscillation is known as the restriking voltage. At the ending of the oscillation, it is known as the recovery voltage. This is the natural current 0. Before obtaining the natural current 0, the current chopping may be obtained. In each and every current chopping, we are observing the magnitudes of the current may be reduced. Magnitudes of the current will be reduced for every each and current choppings. Next one is the resistance switching. Next one is the resistance switching. A fixed contact of resistance in parallel with the contact space. In parallel with the contact space or arc is called as the resistance switching. This is the resistance. This is the circuit breaker. In that voltage, this is the inductance, capacitance, circuit breaker. The fault will be obtained, it may be short circuited. Across the capacitor we are connecting the one resistor. Across the capacitor contacts of the circuit breaker we are connecting the one resistor. It is mainly used for reducing the restriking voltage and transient voltage surges. The resistance switching is mainly used for reducing the restriking voltages and transient surges. A fixed connection of resistance is connected in parallel to the circuit breaker. In parallel to the circuit breaker is known as the resistance switching. Okay, this is the resistance. That resistance is connected across the contacts of the circuit breaker. It is mainly used for reducing the restriking voltage and transient voltage surges. By conducting the resistance across the contact of the circuit breaker, severe voltages may be reduced. Okay, by using this resistor, the severe voltages may be reduced. If the arc is struck between the contacts, the arc is shunted by the resistance. Normally, when the fault will be obtained, this is the fault. When the fault will be obtained, the breaker contacts, the circuit breaker contacts are opened. In that case, the arc is struck in between these contacts. Then that arc will be shunted by using this resistance. That arc is shunted by this resistance. A part of the arc current is divided through the resistance also. A part of arc current is diverted through this resistance also. The resultant decreasing the arc current. It is used for reducing the restriking voltage and transient voltages. By using this, we will reducing the severe voltage drops. When the fault occurs, the contact of the circuit breaker are open. When the fault occurs, the contacts of the circuit breaker are open and an arc is struck between these contacts. With the arc shunted by the resistor, a part of arc current is diverted through the resistance. The result decreases the arc current and increase the rate of deionization of the arc. Okay, thus the arc resistance is increased, leading to the further increases in the current through the shunt resistance R. Thus, the arc resistance is increased. Leading to the further increases in current through the shunt resistance R. This build-up process continues until becomes so small that it fails to maintain the arc as shown in the figure. It is failed to maintain the arc as shown in the figure. resistance is increased, leading to further increases in the current through the shunt resistance. This process is continued until the current maybe becomes too small. Okay, this is while observing this graph. After complete the oscillations, we are increasing the resistance or we are adding the resistance. We are adding the resistance also. Now the arc is extinguished and the circuit breaker gets interrupted. Now the arc is extinguished and the circuit breaker contacts may be interrupted. This is the by observing for the resistance switching. First, it is the starting of the oscillations is known as the recovery voltage. At the ending of the oscillation, the voltage that will be appear is known as the restriking voltage. Okay, at the ending of these oscillations, we will measure the voltage is known as the recovery voltage. But due to the resistance switching, some of the oscillations will be observed. Okay, that is known as the oscillatory restriking voltage. This may be reduced by connecting the resistor across the breaker contacts. Okay, this is the resistor switching. Okay, thank you.